Okay, so we've got 2 lessons left. So I think I got a good news, bad news scenario here. The good news is we've finished most of our unit. And so if you were able to do the questions I just asked you to solve, if you could do that, you'll probably do just fine in this unit. That's the good news. That's the bulk of the unit. The bad news is I still have 2 more topics. And the jump in degree of difficulty is pretty severe. Like going from adding and subtracting compared to multiply and divide, it's quite a bit of a jump. And so is the last topic on solving. So that's why I've kind of planned for 2 days for each of these topics. Today and tomorrow for some time to work on add and subtract, as well as Wednesday, Thursday for some time for the solving ones. So, okay, why don't we get started? The biggest thing you need to keep in mind then, whenever you come across things that are adding and subtracting, I mean, I put it in big capital letters here.
No.
You've heard this before at some point. I guarantee you must have. So, honestly, I think the best way to do this is let's just do some examples. I'm just going to example you to death today. So, let me know. Yeah, maybe not to death, but let me know if you need me to pause or slow down. Also, let me know if you're looking at me going, this is boring, I got this, okay? Maybe, actually, do you mind if I turn that down just a little bit while I'm teaching?
Yeah, how do you turn it down?
Just a knob on the back that you rotate.
Okay.
She's got it. Thank you. Okay, to add these fractions, first let me show you what you cannot do. The correct answer is not 11 over 10. You can't take 5 over 2, add 6 over 5 and say, hey, 5 and 6 is 11, 2 and 5 is, ooh, hang on here, 7. That's not the right answer. You just don't add the 2 of them together. Okay. In order to add them, in a way, it's kind of like adding, let's say that I gave you 5x and I asked you to add 6x. Can you add those together? And I said, sure, that's 11x. But this would be like me saying that you have 5 seconds and you have 6 fifths. Can you add them together? I'd say, well, no, because this thing right here and this thing right here, they're not the same. So first thing we have to do is make them the same. Ooh. My computer's bored. Zeds. Okay. I caught that. Okay. Do you guys remember what to do in a question like this? Okay. Now, just so I'm clear here, we're not to the point of cross multiplying yet. Okay. A lot of kids in a question like this, they think they need to cross multiply and put this 2 up here and this 5 up here. And although that is a skill that we're going to be working with, cross multiplying only applies when there's an equal sign. Now, this is similar to cross multiplying though, in that this 2 right here, we're going to times the top and the bottom by 2. The rationale being that if I times everything by 2, I kind of make it all equally bigger. And this 5 right here, I'm going to times the top by 5 and the bottom by 5. Does that make sense? So now what you have instead is 5 times 5 is 25. And 5 times 2 is 10. But 25 over 10 is 5 over 2. It's just a bigger version of it. We're upscaling, if you like that word, rather than reducing. For so much of your math lives, we tell you to reduce. Here we're actually asking you to unreduce. Here 6 times 2 is 12. 5 times 2 is again 10. 6 over 5 is 12 over 10. It's just it's a bigger version. The issue now is now we have the same thing. We have 25 tenths plus 12 tenths. Do we have the same unit of measurement now? Yeah. So 25 and 12 is 37 tenths.
Can you simplify that or no?
This one here we can't because 35 and 10 don't have any way of doing that. But that's a good point though. We need to keep our eyes open for once we've combined stuff, we should reduce it if possible.
Can you like turn it into 3 and then 7 tenths?
That's valid. They probably wouldn't do it that way, but that is valid. Yeah, I've seen that before. Okay, let's try this one here. So we're not looking to cross multiply, but in a way we kind of are. This 3 right here is going to go on the top, but also on the bottom. I got to make sure that I'm timesing by 3 over 3 and timesing by 2 over 2 and 5 over 5. Because that's really just timesing by 1. This 14 right here, then, you get a times on the top and on the bottom of the fraction. I can't do this in my head. I need a calculator.
It's negative 70
Oh.
over 42
Oh, are you?
for the battle.
Oh, okay. So negative 70 over 42. And that's probably 48 over 42, I guess. Let me know if that stuff doesn't make sense to you. But basically times the 5 and the 14, the 3 and the 14, the 6 and the 3, and the 14 and the 3. Times them all. If you want to write this out in words, this is, I won't write it out in words, but what you have is minus 70 of something, and you're adding 48 of something. So yes, they can add together. What is 70 and 48? Okay, minus 22. So it means you have minus 22 of something, but that something is just over 42. So that's all. Does that make sense? What I'm doing when I'm kind of putting those x's there? You have like terms when you have common denominators. I don't know whether anyone's ever explained that to you before, because I'm guessing you've probably been told get common denominators, but maybe you don't know why. The reasoning why is because common denominators makes them like terms. So you have negative 70, 40 seconds. You have positive 48, 40 seconds. So since you're talking about 40 seconds, you have 22 of them. But make sure you reduce that to negative 11 over 21. Just because 22 and 42 are both divided by two numbers. Environment waster. Okay, does numbers make sense to you guys?
Yeah.
Okay, so now let's try extrapolating this to letters. Yay! Okay, so let's start with the first one here. We need to look for common denominators. Now, the most common things kids will do is they'll try to do this cross multiply thing. And cross multiply, first of all, is not even valid in this case. Because cross multiply is really something you do when you have an equal sign in the equation, and we're not to that point yet. You guys okay?
Yeah, they just did what you just said not to do.
Getting ahead of the game here. Okay, so what we need to look for here is something that is similar between 8 and 4.
X and 2.
Yeah. Let's extrapolate on what you just did though. Here you have an 8, here you have a 4. I don't need to times by 4 and 4 and 8 and 8 because that's a little bit too much. Okay. Hopefully you'd agree that isn't 4 just half of 8? So rather than timesing this side over here, why don't I just times this side by 2 and 2? Wouldn't timesing by 2 get the 8 on the bottom that we need? And then as you look at this thing here, there's x squared on the left-hand side. There's only one x on the other side.
But
So-
times X by 2.
So like do this, is that what you're suggesting?
Yeah.
Because what happens now is I don't actually have to times anything on this side here. It's not necessary to cross multiply this side up over here because that would just be making it bigger than I need to. So what you have now is a 3 of an 8x squared. And then here when you times this, 1 times 2x just gives you 2x of an 8x squared. Because 4 and 2 gives 8 when you times them. And x times this to give you x squared. Now do you have like terms?
Yeah.
Yeah. You have 8x squareds. So you have 3 8x squareds. And you have 2x 8x squareds. Well, can a 3 and a 2x go together though?
Oh,
Okay. So you have to leave it as 3 plus 2x 8x squared. See how I just put the top together?
Whoa.
Can you cancel like one of these x's with that one there?
No, because it's the binomial and the monomial.
Yeah, this guy right here is a monomial. And this guy up top here is a binomial now. So unfortunately there is no canceling you can do. At least on this question. None.
Done.
Still okay with you guys? Okay, let's try another one. Okay, these two questions here, I made a slide up, not so much to practice our common denominators, because as you guys look at these questions here, hopefully you'd agree they already have n as the denominator, or 3q minus 3 as the denominator. So I'm just trying to illustrate something different on these examples. Well, the combining like terms, but very specifically with the minus sign. I find kids make a lot of mistakes when they subtract for some reason. So I'm going to try to nip that in the bud and just point out, be very careful when you see subtract signs. In this particular example here, hopefully you'd agree there's already n's on the bottom. So our common denominator is n. What is m minus m?
0.
Good, yeah, nothing basically. So don't bother writing that. A lot of kids will then say, well, there's a 1 left right here. This m and that m cancel, there's a 1 left. But that's not right.
It would be negative m.
It is negative 1. The reason why is that you have nothing over here, and you're subtracting 1. Can you guys visualize that? Here there's nothing, then you're subtracting 1. What is nothing minus 1?
Minus 1.
It's negative 1. And so you got to be super careful when you subtract, because if you subtract a positive number, it becomes a negative number. But if you subtract a negative number, double negative makes it positive. So let's try the next one. It's got the same sort of thing. The bottom of the fraction is going to be 4q minus 3 because it's already in common. So here there is a negative 1, and you're going to minus 8. Negative 1 minus 8. How much is that?
Negative 9.
You're right, yeah, negative 9. Negative 1, subtract 8 more means you have a negative 9. You also have a 10p, and you're minusing negative 2p. So double negative here, right?
So
10 to something, minus minus 2 really means to add. So 10 plus 2 makes it.
12p.
If it's okay, I'm going to write that at the front of the thing here instead. So, oh, not 12q, 12p.
Look how big the minus sign. That's it?
Well, there is one more thing we should consider. It is sometimes possible to factor and cancel. 12 and 9 do have a number in common. 3. 3 is the common number. So you could factor to become 3 on the top, and then you'd have like a 4p minus 3, and you'd have a 4q minus 3. I don't know whether I did this on purpose to illustrate the point that you actually can't cancel it, can you?
You can?
Why not?
Because it's Q and P.
Yeah. See how this one's a 4p minus 3? And this one's a 4q minus 3? So if they were the same, you could cancel them. But I think I made this question to illustrate the point that these ones can't cancel because they're not exactly the same, but I mean, they could if you made a slight change. What am I doing so far? You guys still with me?
Yeah.
So far I'm just kind of trying to build our way up. I think this next slide is probably the most common kind of question I need to be able to solve. Okay, so this one here is kind of the typical question now. All the previous ones I was just trying to build up to. So here's kind of your common question. You have two different things. You're either going to add and subtract them. Do they have common denominators? No.
So you have to make it.
You have to make them common denominators. And further to that, they have binomials on the bottom. Like these things are binomials. So in order to solve this is again, don't cross multiply because that's actually what you're doing. But see how this guy has a 2x minus plus 1 on the bottom? Well, I'm going to put another 2x plus 1 on the bottom over here. And on the top, I'm going to put a 2x plus 1. I'm not cross multiplying technically, but I'm making it so that I have the same thing top and bottom. I do, but not with 2x plus 1. Yeah, I put them in front myself. I put an x minus 3 right here, and an x minus 3 right here. I'll just kind of bracket this thing up just to make sure it's well bracketed. All right. Bracket is done. For those of you guys who I taught last year, does this ring a bell, this concept?
Yes.
The bigger issue is probably not the remembering what to do, it's now making sure you don't make any little mistakes, because these sorts of questions where you add and subtract, you still have to do the multiply, divide, the simplify, the factoring, the expanding, all those other little skills, you still have to possess them all. You have to do them all in one question. Does that make sense? Because we're now going to do some FOILing. We're going to probably do some factoring at some point as well. We're going to do multiplying of fractions. So we need to make sure that we know all of those skills. The most common mistake kids would make at this point then would be that they'd look at this and they say, hey, I can cancel that. And they'd say, hey, I can cancel that.
So back to where it was.
Yeah. I see that a lot. I mean, I don't mean to make fun and be like, make light of common mistakes, but that's basically just undoing exactly what you did. So try not to do that. What we actually have to do is we have to do some foiling and expanding. My recommendation, don't foil the bottom. There's not a lot of point to foiling the bottom. I would actually recommend you just leave it as an x minus 3 and a 2x plus 1. You can foil, by the way. You don't have to leave it that way, but I don't see any point to that yet. It's the top that we have to do some foiling with now. Hopefully you can see that this 3x has to multiply by both of those two terms there. So if you do x times 3x, you're going to get a 3x squared. And if you do a minus 3 times 3x, you're going to get minus 9x. Is everybody okay with that first little bit? You okay?
Yeah, I just messed with my calculator.
Okay, next key point here. There is a minus sign right here. Be very careful now. That's the most common mistake I think I see kids make. 4 times 2x would be 8x. But there's a minus sign. So now it's rather than being positive 8x, it's actually minus 8x. And 4 times 1 is 4, but there's a minus sign. It's a minus 4. Okay, on the top of the fraction, I have a 4-term thing that can really be a 3-term thing if I just combine the like terms. If I combine like terms, you get 3x squared, you get minus 17x, you get minus 4. And on the bottom, I still don't see any point in actually foiling it out. We could, but it doesn't really help. We're going to attempt to factor the top. So I'm going to make a little note here at this point here. At this point here, you should try to factor and cancel. Else, you are done.
From there?
From this point here. If the top can be factored for some extra bonus canceling, go for it. But if you can't factor the top, you're done. So if we want to factor the top, it means we'd be looking for numbers that add to give the middle number of minus 17 and times to give the outside numbers of minus 12.
Doesn't work.
No, it doesn't. So here's how they might phrase it on the diploma then. This might be the answer. Okay, that's what it might be left as. They might foil the bottom though. So they might make it be like 3x squared minus 17x minus 4. And then the bottom they might foil to give you 2x squared minus 6x plus 1x minus 6. So if I combine those middle terms, I might make that a minus 5x in the middle. So they might write it like that. But in my opinion, I'm content with you leaving it right like this. I don't see any purpose in foiling at the bottom, because if you foil the bottom, then you won't be able to cancel anyways. Does that make sense? Let's try another one. Actually, do you guys want to give one a try without me doing it first? So if you look like you're going ahead, do you want to take 5 minutes here, try it yourself, and then we'll go over it as a group? Try this one yourself. See if you can do it without me. Okay, so it is possible for you to factor out. Yeah, so you can do x plus 12. So although this one can be factored, does anything cancel? Okay. So now I don't know how they'll leave it. I could foresee them making this numeric response, and they'd say that it's like 2a over bc, and then they'd give you like a list of numbers, and like 1 would be this, and 2 would be this, and 3 would be this, and 4 would be x plus 5, 6 would be x minus 17. You know what I mean? And then they'd make a numeric response. But you can either leave it this or this, in my opinion. You could for the bottom too, but again, I don't see anything like that.
Sorry.
Who are we missing today? Laura and Lauren.
Wow.
I haven't seen her in a long time.
She had to do that.
Yeah. It would give you negative 12.
Could if you caught that. Plus 12. Gotcha. I'm just going to start throwing some work up here on the board. Don't look unless you're done. But if you're done, just see whether you have what I have. So, your work might be slightly different than mine, but hopefully it's roughly the same.
Yeah, Keely. Cater. I was in a park from there. But the person was calling after God, and I was like, oh, it's just the card.
Okay, this particular example, it is possible to do some factoring, but you get an x plus 12, and the x plus 12 doesn't actually cancel anything. So I'm not sure how they would phrase this question on a test. So I want you ready for just about anything. They could leave the answer like this. A 2x plus 12, and then the x plus 2x minus 3. That's a valid way they might respond. They could try factoring out the 2 and leave it with an x plus 12, but it doesn't actually cancel. So they could leave it like this. It is also possible that they could write it as 2x plus 24 over x squared minus x minus 6. They could write it like that too. Do you guys know how I managed to get to this particular one?
Yeah, you spoiled it.
I just spoiled the bottom out.
I knew so.
Okay. I don't know what they'll ask, so I do want you to be prepared for any of this, but I would be content myself if you just stopped there. If you went further than that, that's fine by me. But that's what my expectation would be. Did you guys get that one right by yourselves?
Y'all.
Get that one right? Okay. Easy?
Yeah. Not too bad. It's not that bad. The next one I'm kind of confused on.
Okay. So I would say as I break this up into categories, I don't know if you guys ever noticed this as I try to teach a lesson, but I do it very purposefully. Like I try to build our way up little by little. So if you want to look back at the examples we did, these ones right here were only monomials. Then these next couple ones here, like these ones here, were binomials. Well, this one here is also going to be binomials, but there's a twist. Okay? Rather than take this x squared minus 16 and do this, and rather than take x plus 4 and do this, there's actually something extra that you can do. So don't jump right to that just yet, because that's what the point behind this next one is. Occasionally it is possible for you to do some factoring before you start. One of these 4 things is factorable.
That difference of squares.
Yeah, right there. That's the difference of squares.
It's x plus 4 plus 4.
So we should factor that first because it makes our lives a little bit easier, actually. It gives you 32 over an x plus 4, x minus 4. And then you're adding 4 over x plus 4. For those of you guys that I taught this last year to, I would have used a phrase that I think is unique to me. I don't know if you hear it anywhere else, but these guys have what I would call partially common denominators. Because there is already something partially in common on the denominator. Whew, do you guys see what I'm talking about here?
Yeah.
There is already an x plus 4 right here and an x plus 4 right there. So there is no point in taking this x plus 4 and bringing it up here. That's just redundant. That just makes more work for us. Does that make sense? So rather than having to do all of that work, all I have to do actually is recognize that this x minus 4 is the one thing that this guy over here doesn't have.
You gotta add it to it?
So I'll just put 2 of those on the other side. One on top, one on bottom, of course, right? So now I have common denominators. You're going to have 32. We're going to give you a second to catch up here. Don't go too fast.
Oh, it's plus.
So on this one, yeah, don't get too confused if we go back to positives, but be just very vigilant if you see a negative sign, because that's a very common tricky place. So you got to take this 4 and times it by x to get 4x, and you got to take this 4 and times it by minus 4 to get minus 16. And what you're left with is 4x plus 16 over x plus 4, x minus 4.
Like, you can factor 4. Wait, huh?
Okay, yeah, let me not go too fast. You are right, but let's not jump too far ahead here. So I took this 32 and the 16, subtracted them to get me 16.
Oh.
And then I just put the 4x right there.
Oh, I'm a stupid idiot. What are you doing?
Lost you there?
Yeah.
Okay. Any other issues getting up to this step here? Okay, we're not done though. The rationale as to why we're not done is this 4x and 16, there's a 4 in common.
Oh.
So if I factor out a 4, you're left with an x plus 4, which is very purposeful because now there is something that can cancel. The x plus 4s can cancel. So your final answer is 4 over x minus 4. That, and unlike some of the other examples where there's maybe more than one way of writing this one, there is only one way to write this final answer. Like, because of the fact that stuff does factor and it does cancel, there isn't multiple possibilities. Like, this is for sure the right answer. There's no ambiguity to it. Does that make sense? Okay. Let me try one more of this type with you, and then I'll have you guys do the next one by yourself. Maybe. So, okay, so this one right here. Don't write what I'm going to write here. But some people go right to x squared minus 1, x squared minus 1, x plus 1, x plus 1. And that's not helpful because if you recognize that there's a difference of squares here, you can save yourself some time. You could write that x squared minus 1 as x plus 1. She says so sarcastically. Yeah, no, you're right.
Okay, good.
A little worried that she was like being too brash. This guy right here is a difference of squares. So, like I said on the last question, this is not something that has common denominators, but hopefully you'd agree there's something partially in common. So we don't need to times everything. We just need to take an x minus 1 right here and put one up there and down here. So we don't need to put stuff everywhere. We just need to do a little bit of tweaking. Okay, so the bottom of your fraction is an x plus 1 with an x minus 1. And there's a 4. And then there's a 3x and a minus 3. Put your like terms together, you get 3x plus 1 over x plus 1, x minus 1. And since you can't cancel, because you can't factor, and you also can't cancel, like, say, this 1 and this 1, because they're part of binomials and they're different binomials, at this point here you are done. I would say this, though. Be wary of them maybe asking the question like this, 3x plus 1 over x squared minus 1. They could possibly refoil that bottom out again. And this would be a really great numeric response question because they might ask you the answer as ax plus b over cx squared minus d. And then your answers would be 3, 1, 1, 1. Like that. Do you get what I mean when I kind of suggest that as a possible way to phrase it? So I really consider it being my job, especially in grade 12. I want to try to throw all the little things that I think they could test you on so that you're aware of them because I don't get a chance to write the test. So
You don't get to write the test at all?
We have no input as teachers. We barely even get to see them afterwards. So
Since that's straight.
I don't know that it's been since then. More recently, they've been much more secure. They used to actually give us a hard copy to write, and now I can look at it digitally online with supervision for 3 hours. Like, it's a lot more restricted. So. But I mean, my original point was just that I want to try to give you guys as many little thoughts as I can as to what they might try to do to mess with you. So. Okay, why don't you guys try this one? So I've done a couple like this. You guys try this one. Similar concept. Honestly, it's the exact same factor even.
Because it's like a negative sign, it will turn this into a negative.
Yes. Yeah, because you're going to make that a negative 4x, and that'll be a 4, but you'll make it a negative. Good catch on the negatives.
So would it change to a positive 4 after you like subtract it all? Or is it like, or is it still be negative?
Well, because like 4 times 1 was 4, but you've made it a negative
So
4. Yeah, just leave it as negative.
I don't think so. So add to get 4 and minus it. Which one squared?
You're trying to do like one of those things. You just need to simplify out a negative 2. Okay, so let me throw some work up here if you're mostly done. First step should be find that difference of squares. You have partially common denominators. So you just need to throw an x plus 1 on this guy over here. If you do that, you get 2x. That becomes a minus 4x and a minus 4. I just want to make sure everybody catches this minus sign conundrum here because, like I said, it's the most common source of mistakes I find. Here you have 4 times x for 4x. Make it negative 4x. Here you have 4 times 1 for positive 4. Make it negative 4. Make sense? So, last step, you're going to have negative 2x minus 4 over x plus 1, x minus 1. And in my opinion, that's a good place to stop. It is possible to factor the top. But if you do that, you get negative 2 with an x plus 2. And that x plus 2 isn't going to actually cancel anything. So you could factor, but then if it doesn't cancel, the negative doesn't cancel. Did you guys solve that one? Okay, I think I'm going to pause here because I feel like I've given you the basics. Let me just talk about 2 more slides and then we'll call her a day. So here's a slide that has some notes on the steps you're going to take. But after I made this slide, for my 20-1 class that some of you guys took last year, I actually made a flow chart. And you may want to just cut this flow chart out and paste it somewhere. I don't know if it'll help or not. But do you guys remember this flow chart from last year? If it helps, it helps, okay? So basically this walks you through everything that might happen when it comes to rational expressions. So first step, I would say, regardless of what you're doing, factor. Like, factoring will not serve you wrong. You should factor if you can. If you divide, multiply by the reciprocal, like flip it upside down. If you're multiplying, just multiply stuff together and cancel. That's kind of the easy section. The harder section is obtain common denominators. If you are adding, things are good. If you're subtracting, basically make sure you distribute that negative. Don't forget about the negative you subtract. Factor again, if possible, cancel, and then finally you're done. So anyways, if this flowchart helps you, cut it out, paste it on your formula sheet. So, okay. I know I have a few other examples left in here, but why don't I leave those up to you guys? So, well, at some point, okay? So my recommendation might be maybe take those examples, put them in your duotangs maybe, do them there. Or find some other duotang questions. Or if you want to be done for the day, you can be done. Okay. One other thing that's changing, rather than signing out in the office, that hasn't been working very well. If you guys are going to leave the building, can you guys sign out on that clipboard against the wall there instead?
Nice, that's a better idea.
I think so too. Yeah. So for the last 20 minutes here, work on some stuff along these lines. there is a new sheet in the back of the Duotangs that has adding and subtracting questions. Tomorrow, I want to spend about half the class doing some more practice as a group, and then I'll give you guys your next assignment. Okay? That's where we're at.
I don't know.